In this video, I will be drawing a segment of the cell membrane according to the fluid mosaic model, which is also known as the Singer-Nicholson model. And that's our current understanding of what the cell membrane looks like and is made of. So you should be drawing in pencil. The reason I'm drawing in pen is that the document camera doesn't pick up pencil very well. And the way I prepared for this was I just go back in the question bank, which has all of the questions that have been previously asked on IB exams, and I look at the mark scheme. So I look at what Discipuli have gotten credit for, and then I try to teach you to get as many points as possible. So I'm synthesizing these past mark schemes and making sure that I teach you everything that I've seen up here on a mark scheme. So this is going to be a protein. You can be a little creative with the shape. It's going to be a kind of blob. I hope you realize that these circles that I'm drawing are phospholipids. I'm going to draw another protein that's just kind of hanging out on top of the phospholipids, so it hasn't penetrated into the hydrophobic region at all. I'm going to draw a channel protein here. And if you're artistic, you can kind of try to make it look 3D, kind of like a bead. Okay, I'm going to draw some additional phospholipids. I'm going to draw another protein. Okay, so I have 4 proteins here because I want to illustrate the variety of proteins that can be found in the plasma membrane or in the cell membrane, same thing. I'm going to add my phospholipid tails. You can draw them squiggly if you want. What you shouldn't do is leave a giant gap between the tails. So don't do something like this, because that doesn't make sense. We want to make sure that they extend so they're almost touching across the membrane. I hope you remember our heads are hydrophilic and our tails are hydrophobic. And that's why in the watery environment of a cell, they arrange themselves spontaneously in this way. It's like the tails are trying to stay out of the way of the water while the heads are touching the water. I don't have any labels, but I have almost all the components of my cell membrane. I'm going to add some cholesterol. So I remember that just like the phospholipids, cholesterol is amphipathic. So I'm going to represent the hydroxyl head in between those phospholipids. And I don't really want to draw the real structure of the cholesterol. I think that's a little bit much. I'm going to artistically choose to just do some squiggles. If you want to look back and try to draw those 4 fused rings, you're welcome to. But I don't think it's necessary. Okay, so we have some cholesterol in our cell membrane, having its job of making the cell membrane less permeable to water and moderating the fluidity of the cell membrane. I'm going to start to label my proteins. So this protein that extends into the hydrophobic region of the cell membrane is an integral protein. And because it spans the whole cell membrane, we can also call it a transmembrane protein. So you can write that if you want to, but integral protein. And it's distinguished from a peripheral protein. And it's a peripheral protein because it doesn't penetrate into the hydrophobic layer It's just hanging out with the hydrophilic heads of the phospholipids. This is a channel protein. Channel protein allows for facilitated diffusion. And then this is another integral protein. It's not a transmembrane protein, but it is an integral protein because it goes down into that hydrophobic layer. I'm going to make it into a different kind of protein. It's still an integral protein, but it's also, once I add something, I'm going to label this as a carbohydrate. Carbohydrate. And membrane proteins that are connected to carbohydrates are called glycoproteins. Glycoproteins. So it's a glycoprotein. I don't want to forget to label my cholesterol. And then I'm going to change colors because I want to indicate that I understand that this entire thing is one phospholipid, but we also have important regions that we need to demonstrate our understanding of. I'm going to extend that because it's bothering me. So this entire thing is a phospholipid. And then we want to indicate that we know that there's two very important parts. We have a hydrophilic head, a hydrophobic tail. Hydrophilic head, hydrophobic tail. Okay, I'm checking for all my labels. I want to make sure that I teach you anything that I think you could get a point for. So sometimes I've seen that you can get a point for indicating this distance. So I'm going to label that I understand that this is the phospholipid bilayer. And the thickness of the phospholipid bilayer is 10 nanometers, about 10 nanometers. And give me plus or minus 3 nanometers. So sometimes it's a little thicker, sometimes it's a little bit thinner, but that's the range. So we've successfully completed our picture of the phospholipid bilayer using the fluid mosaic or Singer-Nicholson model.